Hello. Today, we'd like to talk to you about the beers and breweries dataset in our data science project. The purpose of this is to share inferences that we made from our analysis with data provided, and hopefully that will guide executive decisions in the future that you all might have. On the agenda today is to explain the beers dataset and the breweries dataset. We'd like to analyze some of the breweries by state, combine the data sets, and to make inferences. And look at the median alcohol content of beers and IBU by state, explore the trends in alcohol content of beers in the US, see if there's any relationship between a beer of its bitterness and its alcohol content, and try to make a model to predict beer types and see if certain beer sizes are sold to different states. So we were first given from the company the beer dataset and the breweries dataset. The beer dataset included different types of beers, their brewery ID, their beer ID, information about a style, alcohol by volume, and its IBU. The breweries dataset also included the breweries, their beer IDs, and location. We took those datasets and first we did analysis of the breweries by state. So using this graph, we can see what states have higher and lower number of breweries per state. And this graph is good because it is able to be quantified using the numbers on top of the bar. We can see that California and Colorado seems to have some of the highest number of breweries. And some of the other states, using the heat map, we can see North Dakota and South Dakota have some of the least amount of breweries. This is a good way to be able to visualize the whole US and see where breweries are densely populated. We also had to tidy up the data that was given to us. We first did this by looking for any null values or missing values in the data set. And we took that data set and was able to take out all the missing IBU units, about 1,000, and missing ABV units. And were able to get it so that there was no missing values. We only use this clean data set so that for analysis that the missing data values would skew the results. Next, we looked into the median alcohol content of beers by state, where you can see Maine has one of the highest. We also looked at the median of IBU beers by state, and the International Bitterness Unit is what IBU stands for. And that had Maine and West Virginia seems to have the highest bitterness in their beers. The maximum ABV beer was in Colorado when we did a search, and the beer was called Lee Hill Volume 5 Belgian Style Quadruple Ale, having an ABV of 0.128. The state with the highest IBU, or International Bitterness Unit, was Oregon. And this beer is called Bitter Bitch Imperial IPA and has an IBU of 138. We also explored the trends to see the ABV of beers in the whole US. And looking at it, we can see that the median of the ABV of beers in the US is around 0.056, and the minimum is 0.001, with the maximum being around 0.0128. We also explored if there's any relationship between bitterness of beer and its alcohol content. By graphing them together, we were able to see that there's a positive correlation between IBU and ABV. This correlation is strongest between the two when ABV is between 0.05 and 0.075. This is good to know for future beer launches. Also, we can see if there's a relationship between IPA and ales, other ales, and leverage that by using a K&N classifier. Using the K&N classifier model, we're able to predict whether it is an ale or IPA with about 88.7% accuracy. Also, we were interested in getting some idea about the bottle sizes and it's sold in each state. We grouped each beer into 5 categories based on their ounces for further analysis. You can see over here is the different categories. By looking at the bar chart, we can see the most common beer bottle size in most states is stubby. In some states, such as Indiana and Michigan, they seem to be more of a long neck and heritage beer size, which ranges from 12 to 22 ounce in every state. There seems to be least amount of the bomber, which ranges from 22 to 32 ounces. This information can help guide future beer launches and what size to prioritize in what locations. Finally, we were able to conduct analysis from different angles. And hopefully the inferences that we made from the data sets can help fuel data-driven decisions on future beer launches and beers that might need to be refreshed. Thank you.